we are required to use linear interpolation to determine a cargo charge, that is y, for a distance of 11 kilometers from Kawale. So what does that one mean? It means that when you're using interpolation, you'll find that actually you have a missing figure and you're trying to find out what could be the value of that missing figure. Okay, so here when you check, here we are given a distance in kilometers and we are given a charge. If you cover 8 kilometers, that is amount of money. If you cover 11 kilometers, we don't know the amount of money. So that's what we are trying to find out, okay? Then Roman 2, they are telling us that we determine distance in kilometers. From Kawale, the cargo would cover after paying shillings 850. So at this point, at this charge, how many kilometers will this cargo cover? Okay, so that's basically what you're interested in, to find out the missing figure in between these values. So they are telling us the table below showed the cargo distance charge chart used by Kamunye transporters from Kawale town on one of their routes. So we are going to start answering this area, and you realize that actually it is not hard. It is not hard. So we are starting with the question 4. That is question 4, March 2022. So we are given the table. We are given the table. So we are to use a linear interpolation. We have two methods, and I'm going to talk about all these two methods. It's you to choose which one is easier. So by using linear interpolation, what is the first method? Method one. This is where you're going to use your equation of line from y is equal to mx plus c. We create the relationship between the independent variable and the dependent variable. We normally use this method. Once you have this linear relationship, you can actually determine any missing figure. Once you have this linear relationship, in this linear equation, all you need is to first get m, that is gradient. Then after getting m, you will need to get c. Once you get m and c, you will be having the relationship between y and x. Okay, you have to first get m, that is your gradient. Remember m, the gradient m is always changing values of y divided by changing values of x. So here m, we are saying m will be change in values of y, then we divide by change in values of x, which is equal to what? So that is basically our gradient. That's how we get the gradient. Okay? That's how we get the gradient. So you need to know that remember you need the y. You need the y. Okay? So for y we use interpolation, and we assume that this 11 and y lies on the same line as this is 8 with 5,000. Then also this is 12 with 18,000. So your 11 and y lie on the same line. So you're going to use these points, 8 with 5,000, then 12 with 8,000 to get the gradient. Okay, so we are going to use point C, point C between the first point is the first one is 8. Remember, we always start with the value of x followed by the value of y. Have points 8 with 5,000, and we have another point 12 with what? 12 with 8,000. So we can use these 2 points to determine our m. We can use these points to determine our m. So you substitute. So when you observe here, what is the value of x1? What is the value of x2? Remember, this is your x1, this is your x2. This is your y1, this is your y2. Okay? So that's what we are going to do, substituting in the formula to get m. Are you done? Just substituting in this formula to get m. Where you have y2, where you have y2, where you have y2, put 8,000. This is 8,000 minus where you have y1, that is 5,000. Then everything we divide by x2. x2 is what? x2 is 12. We subtract 8. Those with calculator, what do you get?
3,000 divided by 4 gives us 750.
This is 750. Perfect. So that is our m. So if we substitute m in our linear equation, we will be having, where we have m, we put 750. Okay. So it means that now our next step is to get c. Our next step is to get c. And how are you going to get this c? You are going to choose any point. Remember, here we have 2 points. We have here 2 points. So you can choose any point. You can choose any point. You can choose this one, or you choose this one. You can say we choose which point. We can say at point, I can choose the first point at point 8 with the 5,000. What will be my value of c? What will be my value of c? Remember, x, your 8 is x, your y is 5,000. So you can substitute in this formula to get c. So where you have y, put 5,000. You are going to say 5,000 is equal to 750x. Then we add, no, now what is our x? 750x, which is 750 times 8. Because we know x now. X is 8. Y is 5,000. We are just substituting in the formula. then plus C. So our C will be equal to 5,000 minus C. If we get 750 times 8, what do we get? 750 times 8.
6,000.
6,000.
We get 6,000. So finally, our C is equal to what? Our C is equal to
Negative 1,000.
negative 1,000. Perfect. So we have our C. When we substitute again in our formula, what will be our value? It will be where we have C, we put negative 1,000. So it will be Y is equal to 750x minus 1,000. So when you have this linear relationship, colleagues, you can actually determine your missing figure. You can actually determine your missing figure. Remember, the missing figure we need is Y. Okay? So at point, so we are going to say at point now, because we need the missing figure. We need the missing figure. At point where you need the missing figure, what is the value of X? What is the value of Y? Here we have the missing figure. X is 11. X is 11. So we are saying at point 11 with Y, we can use this point to get our missing figure. This is your X. You don't have Y. You can substitute in the formula to get Y. So your Y will be equal to, where you have X, put 11. So it will be 750 times 11. Then we subtract 1,000. What will be your value of Y?
$7,250.
It will be shillings, 7,250. So that is your value. When you have covered 11 kilometers, the charge would be shillings 7,250. Is that one too hard? Is it too hard?
No.
So that is the first method. That is the first method. That is the first method. So it means that if you're looking for the value of, let's say, X here, if you're looking for the value of X here, you will still do the same methods. You have point this, you have point 12 and 8,000, then also 16 and 10,000. You first get gradient. You first get gradient using this point and also this point. You get change in the values of Y divided by change in the values of X. Once you get your gradient, choose any point. You can choose this point or you choose this point to get your constant. Remember, once we get the gradient, the next step is to get now C. And when you're getting the constant C, you choose any point. Here we chose this one, but another person can actually choose this. Even if you choose 12 and 8,000 here, you will still get the value of C as negative 1,000. You see here we use the 0.8 and 5,000. Another person can choose 12 and, but wait. Here we had 8 and 5,000. Another person can choose 8 and 5,000. Another person can choose 12,000 and 80,000. You will still get the same answer. Once you get M and C, you can solve any missing figure. What I can say, even if you use this actually, you will see that actually if you're trying to get gradient this and gradient using points this and this, also gradient using points this and this, you will still realize that at the end you have the same linear relationship. So it means that every time you have the linear relationship, you can actually determine any missing figure. Even if another person in your free time, you do that, get gradient, get C. At the end of it all, you will see that you have the same linear relationship. And once you have the same linear relationship, this linear relationship will help you to answer any missing figure here. It means that if you need the value of X here, now you will put at point here, at point, you choose these points at point X and 8,500. You can get the value of X because this will be your Y, where you have Y here, put this figure. Then look for the value of X. Okay, another method, all you want to do, colleagues. Are you going to use the same method to get X?
Ask something.
Yes, we shall do it in our time.
Yes, just where you have Y, put 8,500, where you then look for the value of X using this formula. But if you want to prove, you get gradient. After getting gradient, look for the constant C. You will still get the same formula. Okay, method 2.
Abby,
Yes, please.
I wanted to ask about something.
Yes.
Suppose in interpolation, in the table, and you're not given some unknown, how do you go about it when there are no missing figures?
When they are not missing.
There are no missing figures in the table, and you're being asked like to use interpolation and maybe extrapolation. How do you go about it? For now, it is interpolation.
Or message or whatever it is, whenever, even if it is extrapolation, even if it is interpolation, still the method will remain the same. You get the same things. You just need the same concept. Because now with just to know that with extrapolation, the missing figure is not in the table. It is outside. Yeah? It is outside. Let's say it is this side. And if it is this side, just for you, you need this point, to get what is outside, and you apply the same concept. Interpolation figures, the missing figure is in between. Like here, you are seeing that you are using point this and point this. Then if it is interpolation, rather extrapolation will be like this. Extrapolation, you'll find that you have, let's say here Y, and here you have, I can call it K. Then here you have, let's say 20,000. In such scenario, you are using here where you have interpolation, you using linear extrapolation. Because with extrapolation, the missing figure is outside your table, initial table. The missing figure is not in between these points. Then method two is just where you are going to just say and start with Z. Where you have 2, you put 3. Then where you have X2, you put X3 is equal to, then here to from, another person can say from this, then you substitute immediately without looking for gradient, without looking for C. So you come back at your table. This is your table. This is X1, this is X2, then this is X3. This is Y1, this is y2, then this is y3. You substitute in this formula and get the unknown. So we can substitute. Our y3 is what? Our y3, when you check, our y3 is 8,000. 8,000. Then we subtract our y1. Our y1 is 5,000. I'm not going to do everything, just I'm substituting, you will finish. Then your x3 is what? Your x3 is here. Because we are using these points, okay? We are using these points. So this is x1, x2, x3. So x3 is 12. Here x3 is 12 minus x1 is what? X1 is 8. Then we say is equal to what is our y2 in that question? Our y2, do we have y2? Y2 is just y. So this will be y, the figure you are trying to get. This is y minus y1. Y1 is 5,000. Then what is your x2? Your x2, now these are values of x, x1, x2, x3. This is x2, 11. So we say 11 minus 8. So once you have that, you can get the unknown. So it's just a matter of using your calculator very well to get the unknown y. So it's up to you to use the method that is easier for you. You will still get y. You will still get y as, if you solve, you will still get y as shillings 7,250. But continue and finish. So which method is easier? Both are easy, all of them are not hard, isn't it? So that is our question. So from that, they are telling us we look for what? What is the next? Roman 2, they are telling us that we determine in kilometers, that is X from cover, the cargo would cover after paying 8,500. I said you are going to do this. Use the same knowledge. Already you have the linear equation. The beauty with the first method is that you'll be having linear equation. Okay, so you can immediately say at point X, then 8,500, what will be the value of X? But if you have used the method 2, then you are going to again work, get y3 minus y1, because this will be your x1, x2, x3. This will be your y1, y2, then y3. But someone who has used the method, method one, you just need to substitute in your linear equation. So colleagues, you are going to finish. You are going to handle this, isn't it? Are you going to handle?
Yes.
Yes.
Because it's a matter of substituting in our linear equation. Remember, this is our linear equation. And if you realize that even here, when you are trying to get changing values of changing y3 minus y1, then x3 minus x1, what you are trying to do here is to get gradient. Yeah. So method one is still okay. So we go to the next question. We go to the next question. Part C, that's what I'm interested in. They are saying using matrix method, find the total cost of assembling a car. Are you seeing my screen?
Yes.
Yes.
So they are telling us that a new car dealer in Namanve Industrial Park assembles two types of cars, Sunny and Easy. On a certain day, he assembled 4 Sunny and 2 Ice at a total cost of shilling rupees. If you assemble 4 Sunny and 2 Ice, you're going to incur the total cost of this. That is the first day, on the certain day. Then the following day, he assembled 3 Sunny cars, then 1 Ice at a cost of this. So it means that here, it's a matter of interpreting your case. It's a matter of interpreting your case study. So we are going to say rate. You can say rate X or Y, but I can use S. Let S be the cost, because we don't know the cost of assembling each car. That's what we are trying to find out. Find the total cost of assembling each car. Here, what you have is the total cost the company incurred. The total cost the company incurred to assemble 3 Sunny cars and 1 Ice. Then here to assemble 4 Sunny and 2 Ice but we don't know the cost this person is incurring or this company is incurring to assemble just one car. That's what we are trying to find out. Let S be the cost. Be the cost of, let's say, assembling. If you to assemble just 1 Sunny car, how much are you going to incur? That's what we are trying to find out. Then let another H, because we have this, let be the cost of assembling. Be the cost of assembling okay. So once you do that, first day, you observe that first day, something happened. First day, when you observe, on the certain day, he assembled 4, but we don't know if there are 4, how many are, okay, we know the number. How much is the cost of assembling the Sunny car? So we get 4 times S, because we don't know that value, we don't know that cost. So we get 4 times S. Then here we get 2 times H. So here it will be here it will be 4 S plus C. If we get 4S plus 2H, we will get what? The overall cost. The overall cost is how much? The overall cost is 80 million. The overall cost is 80 million. Then on the next day, this is first day. Then on the following day, second day, they are telling us the following day he assembled 3 Sunny. We want to know, okay, if you assembled the 3 Sunny cars, what is the overall cost? But we don't know the cost for assembling even one Thaneka. But that cost we have defined it to be S. So we get 3 times S, then we add 1 times H, then everything we get, we equate it to 50. This is a 3S plus 1 times H, which is H. It will be equal to what? How much? 50. It will be equal to 50. So those are your equations. But we are using matrix method to solve these equations. If they didn't specify, you can use any method. You can use elimination method to get H and S. But here they have specified you use matrix method. So using matrix method, you need to first create this in matrix form. These are your 2 equations. You need to form a matrix. That is our matrix. Number 1, we have formed the matrix. Then the next step is to know that as you solve this, you will use the inverse. You will use the inverse. You will need to get the inverse. Just first say let A equal to this one, this capacity bracket. Let A equal to the first bracket. Then you get the inverse of A, then you get inverse of A, multiply it both sides. If I say both sides, I will multiply it here. I also multiply it this side because I have one side on the left. This is left side, then the right side. Once I get my inverse of A, I multiply it to both sides, and I will be in position to solve. So, what is the inverse? How do you get inverse of matrix? Inverse of A, or you can write it as A, as that. Someone can say inverse of A, or can just say A up to A power -1. That is, this one represents inverse. Is equal to, colleagues, do you recall how you get inverse? Primary work. Inverse of A is equal to 1 over determinant of A. This is 1 over determinant of A. This is 1 over determinant of A. Then we multiply by the cofactors. We multiply by the cofactors. Cofactors of A. We multiply by cofactors of A. That's how you get inverse. But what is determinant of A? What is determinant of A? Determinant of A is equal to, do you recall how we get determinant? Do you recall these things? My major diagonal minus minor diagonal. Do you recall those things? Huh?
Yes.
So here, this is our A. This is our A. This is our A. What is major diagonal is this one. 4 is 1. That is major diagonal. Then minor diagonal is this one. So when you're getting a determinant of A, you just multiply those figures on major diagonal. It is 4 times 1. So that the figures on major diagonal. Then you subtract figures on you subtract figures on what? On minor diagonal, but you multiply them. 3 times 2. What do you get? This is 4 minus 6, and your determinant is equal to what? -2. Are you understanding? Major diagonal, we multiply figures on major diagonal, then we subtract the multiplication of figures on the minor diagonal to get determinant. So on our formula, we have determinant of A. We can get cofactors now. Cofactors of, we can get cofactors of A. Cofactors of A. And how do you get cofactors of A? Now, this is your A. This is your A. You interchange to get cofactors. To get cofactors of A, I will interchange. I interchange figures on the major diagonal. Interchanging means what? If 4 is here, I put it for this side. Then this one I put it. It's like if you are interchanging, 1 will be here, then 4 go this side. We are interchanging figures on the what? We are interchanging figures on the major diagonal. This is major diagonal, we interchange. That's what I have done. Interchange figures on the major diagonal. Then you change sign on your major diagonal, on your minor diagonal figures. We change the sign. We don't interchange the minor diagonal, we only change the signs. If it is +3, now we are changing the sign to negative what? To -3. If it is 2, now we are changing the sign to negative what? To -2. So major diagonal, you interchange. Minor diagonal, you change the signs. And that will be your cofactors. Have you understood how we get cofactors?
Yes.
Once you get cofactors, we substitute in our formula. We substitute in our formula. Inverse of A will be equal to, we substitute. Where you have determinant, put -2. Already we have our determinant as -2. Then I multiply by the cofactors. I have my cofactors, so I multiply them here. So this will be equal to what? So once you reach here, in this step, what you're going to do is to put everything, put what you have outside the bracket. This -1/2, you're going to multiply this -1/2 to every figure in the bracket. Get -1/2 times 1. Get -1/2 times -3. Get -1/2 times -2. Get -1/2 times 4. because we are trying to get inverse of A. If you open brackets, what do you get? A half times 1, what do you get? A half times 1, what do you get? You get negative what?
Negative a half.
Negative a half. That is 0.5. 0.5. Negative 0.5. Then if you get negative a half times negative 2, what do you get?
1.
Positive, negative.
Positive.
Positive 1.
Then a half times negative 3. This is like 1 times negative 3 divided by negative 2. What do you get?
Negative 1.5.
Are you sure you're getting a negative? Because this is negative
It's
3.
positive 1.
The positive.
Positive what?
Positive 1.5.
1.5.
1.5.
Then here, this is like 1 times 4, then divided by negative 2. You get what?
Negative 2.
Get negative 2. So this is our inverse. This is our inverse. We are going to multiply this inverse, both what? Both sides.
Both sides.
Remember, this is your matrix. So this is left side, this is right side. You multiply this inverse, both sides. So I will get this. I will get this. Then I multiply by, now I write everything here. Is equal to, then I also get this. Because I was saying, well, multiply it both sides, then I multiply by what I had this side. So we have here, we have multiplied our inverse of A both sides. So we have to now to apply our rule. We have to apply our rule. Okay. You're getting this matrix times this matrix. Remember, when you're multiplying matrix, it is row by what? It is row by column, row by column, row by column. So what will happen is, so we want to actually multiply this matrix into this matrix. We are saying you get row, this is your row, this is your first row. So you get row times what? Times column. We are going to get this row, this first row, this first row. Then we multiply by the first column. First row, then we multiply by the first column. So you get negative 0.5 times 4. What do you get? Negative 0.5 times 4, what do you get?
Negative 2.
You get negative 2. So here it is negative 2 plus 1 times 3. What do you get? You get 3. Then here, negative 0.5, because we have to multiply row into all the columns. Negative 0.5 times 2, what do you get? Negative 0.5 times 2.
Negative 1.
You get negative 1. Then plus, you are done with the first figure. 1 times 1. You get positive what? You get positive 1. Then here, You are done now. You are done with this first row. You are done with this first row. We go to the next row. Remember also the next row, you will do the same row times what? Row times column. You get the row, you multiply by all columns. So it is 1.5 times 4. What do you get? 1.5 times 4.
6.
You get 6. Then
6.
plus negative 2 times 3. What do you get?
Negative
6.
6.
Plus negative 6. You're done with this first row. So also get this row, multiply it into the next column. 1.5 times.
Heaven.
Yes, please.
Heaven.
Any question? Okay. 1.5 times 2, what do you get? You get 3. Do you get 3? Then plus negative 2 times 1, which is negative 2. Okay. Then you multiply by this is equal to, we do the same this side. We do the same. Because this one also you're going to get a row multiplied by the column. This is like your column, this one. This is a column. So you do the same in a matrix form. So you do the same. We get our row. This is our row. Negative 0.5 multiplied by 80 million. What do you get? Negative 0.5 times 80 million. You get negative. Here we will be having only. Sorry about that. You get negative 40 million. Then add 1 times 50. You get 50. Okay, you are done. So it means that we don't have this. We can just get this. We get 1.5 times 80 because we are done with the first row. We get 1.5 times 80. 1.5 times 80, what do you get? 120. You get 120 million. Then add negative 2 times 50, you get negative 100. Negative 1, negative 100. So it means that we don't have this. Our matrix is just stopping. Then what will we get if we open brackets? If we open brackets, what are you going to get? If we open brackets, If we open brackets, the first bracket, it is giving us what? Here, what are we getting? -2 plus 1, what do you get?
1.
1. Then here, what are we getting? -1 plus 1, we get 0.
0.
Here, you're getting 0. Then here, you're getting 1. Colleagues, this is very key. When you don't get those things, know that you have multiplied wrongly. Know that you have multiplied wrongly. The diagonal must be the same as your diagonal must be the same as here we are multiplying it by this. We are multiplying it by this. Then is equal to, if you open brackets here, what do you get?
You get 10 million.
The
Huh?
first one is the first one is 10 million, okay?
Yes.
Then down is what?
20 million.
This is 20 million. This is 20 million. So this implies that basically, if you open this matrix, if you open this matrix, this one, if you open this time this, it means that it implies that basically your S will be the first figure up, 10 million. S is shillings, 10 million. You are done. You are done with the number. Then your H is shillings, 20 million. And you're done. Because we are looking for S and H. If you substitute these values in any of the equation here, you will get this. Where there is S, you put what you have calculated. Where there is H, you put 20. You will still get these things. And that's all. Any question? That's how we use matrix method. Is it too hard?
Not really.
So this question, they are telling us that on the required part, we determine the number of passengers. We determine the number of passengers who traveled in each category on the first bus trip. Then Roman 2, we determine the total income earned from the fares the bus company got on the second trip. So we have to analyze our case study. And they are telling us that BAK bus company travels daily from Kampala to Mityana and accommodates 3 categories of passengers. This bus travels from Kampala to Mityana every day, and they accommodate 3 categories of passengers. Business class, that is the first category. A first class, that is the next category. Then the economy class. I don't know where you fall. And remember, on the required part, they are telling us we determine the number of passengers who traveled in each category. Okay, passengers are required to pay shillings 5,000, 7,000, and 4,000 respectively on the preferred category. That's what passengers are required to pay. If you fall under business class, then you pay this. If you fall under first class, you pay 7,000. Then under economy class, you pay 4,000. Okay, the bus can only accommodate 100 passengers on a single trip. Remember, a single trip, they are telling you, can only accommodate 100 passengers. But in this trip, recall that a bus can accommodate 3 categories of passengers: business class, first class, and what? Economy class. So it means that if you sum up category for business class, first class, and economy class, then the total passengers should not exceed this. So it means that ideally, when you're interpreting this is where you have equation. Here you have the equation. Here you have the equation. Recall those words I used to tell you every time you see something like this, only accommodate one. You need to know that the equation, okay? So here we have the first equation, but we will need it first to define. We will need it first to define. We will need it first to define. We say rate, we can say rate. I may say B, because the wording is okay. B the number of passengers. Let B be the number of passengers. Number of passengers used. That number of passengers that used. Number of passengers that used. That used the business class. Number of passengers okay. Then B. Then next, that is BF. F can represent passengers under first class. Then C, passengers. No, this is not C, this is E. This is E. Passengers for under economy class. This is passengers This is passenger that fall under first class. So you have defined, So you have defined, and you observed that from the first trip, the bus can only accommodate 100 passengers. So if we get B plus F plus E, it should be giving us what? Should be giving us 100 passengers, and that is your equation. That is your equation 1. So we interpret the next statement. The bus can only accommodate 100 passengers on a single trip. And on the first trip, this is what we are handling. Shillings 660,000 was collected as fares. Okay. So it means, recall that this is like the money paid. This is like the money paid. Here you are correcting. Remember, each category here pays this amount of money. Each passenger, here each category pays this amount of money. So it means that we can also form another equation from this. If we get 5,000 times B plus 7,000 times F plus 4,000 times E, it should give us what? It should give us this. So here the next is to form another equation, 5,000 B plus 7,000 F, then plus 4,000 E. If we sum up the amount corrected is how much? 630,000. That is your next equation, but you can reduce it. You can reduce it since you have a common factor by dividing everything by 1,000. So if I reduce, we can reduce by every figure by 1,000. Here we will have 5B plus 7F, then plus 4E, and it is giving us this. This is our equation. This is our equation 2. This is our equation. We continue interpreting. On the second trip, now we are done with the first trip. Now we are on the second trip, on the second trip. On the second trip, they are telling us what? On the second trip, they are telling us that the bus, the business class, recorded 10 more passengers. What does that one mean? Recall that you have said that on the first trip, this is your B. This is the number of what? This is the number of passengers that fall under business class. But on the second trip, they are telling us that business class recorded 10 more. So it is B plus 10. Okay. Then first class had 20 passengers less. First class had 20 passengers less. So what does that one mean? It means that if initially you had F, now it will be F minus 20. Because you don't know the number of what? You don't know the number of passengers. Just that you know that the number of passengers that fall under first class are F. And on the second trip, they are telling you that the number reduced by 20. So to get the new number, we will get F minus 20. Okay. Then the next, they are telling us that while the number in economy class had doubled as compared to the first trip, had doubled. What does that one mean? Had doubled. What does that one mean? If initially it is E, Then the double of E is what? 2 times E. 2 times E. Remember that the bus can only accommodate what? Remember the bus can only accommodate 100 passengers. The bus can only wait. Yes, the bus can only accommodate 100 passengers on a single trip. Whether it is a first trip, whether it is a second trip, just know the bus can only accommodate 100 passengers. So it means that the overall, however much here passengers are increasing, here reducing, here doubling, we all know that the bus can only accommodate 100 passengers. So if you open brackets, this will be B plus 10 plus F minus 20, then plus 2E. Plus 2E is equal to 100. If you correct like terms, this is B. This is B. This will be our B plus F plus 2E plus 10 minus 20, which will be 100. So this is B plus F plus 2E, 10 minus 20, you get negative 10 is equal to 100. So finally, I have B plus F plus 2E, which gives me what? This one will go this side and it will be 110. And this is equation what? This is equation 3. So you're going to solve equation 1, 2, and 1, equation 1, 2, 3, using any method you want. Using any method that you want. You can use elimination method, simultaneous method. So this is the first one. So we can solve. I'm going to start with elimination method, using elimination method. This is like simultaneous method also. So we are going to solve. If you have 3 equations, the question is, can you solve these 3 equations or not? So we are going to solve equation 1, 2, and 3. But when you're having 3 equations, solve them. You will first handle equation 1, solving equation 1, solving equation 1, solving equation 1, equation 1, equation 1 and 2, equation 1 and 2. Remember, our equation 1 is this one. Then that is our equation 1. Then our equation 2 is this one. That is our equation 2. We want to solve this. So we are using elimination method. So out of 3 variables, we can eliminate 1. We can decide to eliminate B, we can decide to eliminate F, we can decide to eliminate E. But I am going to just eliminate B. So you want to eliminate B? how can you eliminate B? I'm going to put here 5, then I put here 1. Then once I do that, I get 5 times B, that is 5B, plus 5 times F, that is 5F, plus 5 times E, that is 5E. Then everything is equal to 5 times 100, that is 500. Okay. Then the next I get 1 times 5, that is 5B. Then I add 1 times 7F. I add 1 times 7F, that is 7F, then plus 4E, which will be equal to 630. So once I have that, I can here we are going to subtract. What do you get if you subtract the first figure? If you subtract here, you will get 5B minus 5, that is 0. Then plus, if you get 5 minus 7, that is negative 2F. If you get 5 minus 4, that is plus E, because that will be 1E. It will be equal to 500 minus 60, that is negative what? Negative 130. Negative 130. So this implies that negative 2F plus E, which is equal to negative 130, is my equation 4. Okay, that is my equation 4. Then I go to the next. I solve equation. I can say 1 and 3. Equation 1 and 3. Because I have now solved the equation, have already solved the equation 1 and 2, I can choose 1 and 3, or another person can choose 2 and 3. We want to create a relationship like this from equation 1 and 3. If you focus on equation 2 and 3, then also create a relationship in this form. So equation 1 and 3, remember our equation. Our equation 1 is this. This is our equation 1. This is our equation 1. Then equation 3 is this one. Equation 3 is this one. And I want to eliminate what? You want to eliminate. Remember, as you solve equation 1 and 3, you want to eliminate the figure you eliminated. Solving you want to eliminate the unknown you eliminated when you are solving equation 1 and 2. So even here we are going to eliminate B. We are going to eliminate B. Okay, if you subtract, what will you get? Because like at this point, what you have is like here. This B is, you have the same figure here, the same figure here. So you can eliminate B. So here we have the same 1, 1. So we can easily eliminate what? We can easily eliminate B. So what will happen is you get F minus, here things are becoming very easy. This one is becoming very easy. So here it will be B minus B, you get 0, plus F minus F, you also get 0, then plus E minus 2E, what do you get? You get negative E, negative 1, that is negative E. Then it will be equal to 100 minus 110, that is negative 10. Implying that now, from the solving equation 1 and 3, you have E. You have negative E, which will be equal to negative 10, implying that E is equal to 10. Now you have E. But if you solve equation 1 and 3 and you don't get this, it means that here, as you solve equation 1 and 3, your focus is to create a relationship in the form of F and E, so that you can solve equation 4 and 5 simultaneously. Because other questions, you'll find that at this point, you are not getting E. You are getting, let's say, F plus 2E, then is equal to negative 10. In such scenario now, you will be having F and E. You can solve equation 4 and 5. Also, you eliminate out of F or E, you eliminate one unknown by using the same concept we are using here. But here, after solving equation 1 and 3, you realize that we have what? We have negative 10. We have negative 10, and our E is Z. So we can say substitute E is equal to 10 in equation 4. Substitute E is equal to 10 in equation 4. Remember, your equation 4 is this one. This is your equation 4, where there is E, put 10. So this will be negative 2F plus 10 is equal to negative 130. So negative 2F is equal to negative 130 minus 10. Then 2F is equal to negative 140. And finally, your F is equal to, if you get 140 divided by 2, 140 divided by 2, that is 70. So you have F. You have F. We are left with what? Now, we can substitute E is equal to 10, F is equal to 70 in any equation. It can be equation 1, it can be equation 2, it can be equation 3, any. So we substitute E is equal to 10 and F is equal to 70 in equation 1. This is our equation 1. So you can substitute. Where there is, will be 5, this will be 5B plus where there is F, I put 70 times 70, then plus where there is E, I put 10. This will be equal to 6. But is this equation 1? This is equation 3. This is equation.
Equation 2. It is
Equation
2.
is 2. This equation
Yeah.
is 2.
Mm.
Oh, yes, it is equation 2. Okay. But I said you can substitute in n, you will get the same answer. Another person can substitute in equation 1, or another person can substitute in equation 3. So this is 5b, 5b plus 7 times 70, you get 490, then plus 40, which will be equal to 360. This is 5b. If you sum up those two figures, what do you get? You get 530, which will be equal to 630. So your 5b is equal to 630 minus 530, and 5b is equal to, is it 100? You divide, your b will be equal to
20.
your b will be equal to 20. Your b will be equal to 20. So another person who has used also equation 1, you'll find that your b is what? Is 20, because here it is our f was what? 70. Then our e is 10. 70 plus 10, that is 80. 100 minus 80, that is 20. So you will get the same, answer. So we have answered Roman 1. That is the number of passengers who traveled in each category on the first trip. Then Roman 2, they are telling us we determine the total income earned from the fares the bus company got on the second trip. On the second trip. Here we are looking for what, colleagues? We are looking for the total income. And so how are you going to do? How are you going to calculate that? How are you going to calculate that? Of course, already you know that passengers are required to pay this amount of money. Every person, the category, passengers are required to pay shillings, this, and this. Okay. So what we will do is to look at what was our second trip. This was our second trip. Of course, with second trip, that is Roman 2. Based on the second trip, if you handle business class, second trip is 10 plus what? B plus, is it B plus 10? Which will be, your B is 20. B is 20, then plus 10. It means that on the second trip, you had 30 passengers that fall under business class. So if we multiply by what? We get 30 times Z. If you follow under business class, how much do you pay? Business class, it is what? 5,000. First class, it is 7,000. Then economy class, it is 4,000. So we are handling. So here you will multiply by 5,000. And that is shillings. That is shillings 150. 157. These are passengers. Then for first class on the second trip, first class, you have how many passengers on the second trip? They said because when you follow what we are doing, it is F minus 20. F minus 20, which is what your F was what? 70? 70 minus 20. And you get 50 passengers. But we need the amount. So this is 50 times the first class. How much are they paying? First class, they are paying 7,000. This is 7,000. And the amount is shillings.
350.
350. We do the same for the next class, which is economy class. With economy class, the figure they told us the passenger will be double. So if you get to E, that is 2 times what was our E? Was 10. Was it 10? Yes. So this is 20 passengers. And the amount would be 20 passengers times each is paying how much?
4,000.
4,000. And this is shillings 80. But they are saying we look for the total income. So total income you are going to add, get 150. Total income collected. This is 150 plus 350. Then plus 80. Yeah, how much do you get?
580.
Pardon?
580,000.
580,000. So that's all about that question. That's all about that question. Now, I want to use another method. If you are in an exam and you forget, you see this is not hard, you see that this is hard for you, you can use another method. Using another method to get F, E, and what? And B. You can call it matrix, you can call it, most normally call it Cramer's rule. They ask you that, don't say you didn't study. So, already we have our equations. We have our equations. We have equation 1. Equation 1 was what? This is our equation 1. Then this is our equation 2. Those colleagues, they can ask you to use Cramer's rule. No, examiners are funny. Remember, it is part of the matrix. It's better also to me. Okay, we have 3 equations. This is related to matrix. And with Cramer, it is not hard. Just form the matrix. Here you have 5. Here you have, no. Here you have 1. Here you have 5. Then here you have 1. Then here it is 1. Then this is 2. Then this is, what am I doing? This is 7. This is 1. This is 1. This is 4. Then this is 2. Then followed by, once you form the matrix, the next step is to do what? Is to rate the same way we are doing for the other first number. Let A equal to, we are trying to get the determinant here. Let A equal to the first matrix here. Let A equal to this. Then you look for determinant of A. Determinant of A, which sometimes can be written as can be written as determinant of A can be written as this. This stands for determinant. It will be equal to. Now, how do you get determinant of a 3 by 3 matrix? How do you get a determinant of 3 by 3 matrix? Remember, in the first question, we saw how we can get a determinant of a 2 by 2 matrix. How do we get a determinant of 3 by 3 matrix? What you will do is to write this one. You write this one. Then once you write that one, then we have written this one. Hide this row and hide the column where this one is. Hide the row where one is, then also hide the column where this one is. You'll be left with 7, 1 and 2, 4. You'll be left with this column. 7, 4, 1, 2. If you hide this one and this one. So you get 7 times 2. If you get 7 times 2, what do you get? This is 7 times 2. Maybe for purposes of people will refer later, minus 4 times 1. It can be 1 times 4 depending. Then next, when you start with the positive, the next here you put negative. Minus what? Minus what? What is the next figure? The next, we are done with this first figure. We go to the next figure, which is 1 also. 1, we repeat the same steps. 1, then open brackets. 1, then open brackets. We are hiding now where this one is. We are hiding this row where this one is. We are hiding the column where this one is. So you will be left with what? If you hide this and this, you'll be left with 5, 1, 4, 2.
5, 1 and 4, 2.
Yes, so we are getting 5 times, remember 5 times 2. Then minus, open bracket.
1 times 4.
1 times 4. We are done with that one. This is, we started with a positive, followed by negative. No, it is positive, followed by this negative.
Yeah.
Okay, after negative, we are going to plus. That is the trend.
Plus.
Positive, negative, positive. And now we are going to the next figure. Hey, the next figure is also 1. Okay, don't cram that it should be 1, 1. No, it depends on what you have up. Are we together? It depends on what you have up. So we are saying 1. We again open our what? Our brackets. We again open our brackets. So it will, now what are we hiding? This is where 1 is. We are hiding,
We are hiding 4 and 2.
1, 4, and 2. Then, so we will be getting 5 times what? 5 times
1. 1.
5 times 1 minus, open the bracket.
1 times
1
times 7.
You're done. You're done. Just now open bracket and get open your brackets and get your answer. So this will be what? This will be 1 into. This will be 1 into what? If we open bracket 4 times rather 7 times 2, that is 14 minus 4. Then minus 1 into, now we are on the next step. 5 times 2, that is 10 minus 4. 1 times 4, that is 4. Then plus 1 into, this is 5 times 1, that is 5, minus 1 times 7, that is 7. So this will be equal to, 1. Finally, you have, here you have 1 times what? 1 times 10 minus 1 times what? If you open this
6.
bracket, 1 times 6.
It is 6.
Then plus 1 times 1 times, if we open the bracket, what do we get?
Negative 2.
Negative 2. So finally, our determinant is equal to, this is 10
minus 6
minus 6,
minus 2.
And finally, we have what?
You have 2.
So that is your determinant. That is 2. Once you get that, know that life is now easier. How are you going now to get, once you get the first determinant, now to get, remember what are we interested in? We are interested in to get B. How are you going to get B? B will be equal to, your B will be equal to, that's how you are going to get B. Determinant of capital B over determinant of capital A. But the question is, do you have determinant of capital B? Do we have it? We don't have. So it means that we need to get matrix B. Let B equal to what now? Let B equal to, remember, B, when you observe our equations, B is on the first column. Are you seeing that? So you're going to replace this column where B is with this matrix, with this column. This column here where B is, you replace it with this column. So it will be, you write this, but where you have one, you put what? 100. Where you have 5, you put what? 660. Then where you have 1, you put 110. Once you get B, then look for determinant of B using the same steps. Look for determinant of B using the same steps. Same steps we are using here to get the determinant of A. Same steps. So, same steps. We start with what? The first figure here is what? 100.
100.
Then we open brackets. Open brackets. Here we are putting, which one are we hiding?
We are
We are
hiding
hiding
100.
first row and the first column. So we are left with what? 7 times 2.
2.
Then minus, open bracket.
1 times 4.
1 times 4. Close bracket. Next, remember you start with positive, then followed by what? Negative.
Negative.
So once you write negative, write the figure you have here, which is 1.
1.
So we also repeat the same steps. Repeat the same steps. Here, it will be what? It will be what are we hiding? We are here.
1. We are hiding 171.
We are hiding this and this. So it will be hiding this and this. It will be 6 what? 630.
6 times 2.
Times 2. Then minus, we are hiding
110.
110.
110 times
Yes.
4.
110 times 4. Then after minus, we got what? Plus.
Plus.
Figure you going to write 1. You write 1. Then times, now we are hiding this and this.
And
So we are getting, where is 7, we are going to get, we are hiding this and this, which is 330 times what? Times 2?
1.
No.
Times 1.
Because we are hiding this column. Then minus
110 times 7.
10 times 7. Perfect. Then finally, what will be your determinant of B? It is 100 times, just use your calculator. If you get 14 minus 4, what do you get? 14 minus 4, that is 10.
10.
Then minus, what is our next? This was our next. We are here. If you just get 1, you get 1 times. Use your calculator. You can use your calculator direct. Open bracket, 360 no, 630 times 2, close bracket, minus, open bracket, 110 times 4, close bracket. What do you get? You can just use
800. 820.
820.
820.
Okay, then plus,
Yes.
we are here now. It is 1 1 times open, just use your calculator, open bracket 330 times 1 close bracket minus open bracket 110 times 70 equal signs. Look what?
Times negative 140.
So finally, you can also put everything on your calculator. Just open bracket 110, or rather 100 times 10 close bracket minus open bracket 1 times 820 close bracket plus open bracket 1 times negative 140. What do you have? So that is it.
The first bracket is 1000.
No, may I need the
The
final.
overall answer,
Yes.
it is 40.
So once you get 40, we can get our value of B, the unknown, the one we want. B is equal to, remember this method should give you the same figures like the first method. So B is equal to,
Determinant of B.
we get 40 divided by, already we have determinant of A,
Yes.
which is 2. So B is equal to what?
20.
That's what you had initially.
Yeah, that is what we had in the first equation, a first formula.
The first method is 0. Rather 20. So you use the same knowledge. You use the same knowledge. Now, right here, once you get to B, you will need F. How do you get F? To get F, it will be equal to get F, it will be now, but where I have B, I put what? Capital F. So that I first get matrix of what? Matrix of F. What you have down will remain the same. Determinant of F for it will remain the same. What will keep on changing is where you have, if you are looking for B, you need determinant of capital B. When you are looking for F, you need a determinant of capital F. Then when you're looking for E, you need determinant of capital E. So do you have F matrix F? You can form matrix F. I am just going to form matrix F. You will finish everything.
Okay.
Matrix F. From this, we are, remember, where do you find, which column do you find F?
The second column.
Second column. So we are going to replace this second column with this. We replace second column with this. Where I have 1, I'm going to put what? 100.
100.
Then where I have 7, I'm going to put what?
630.
I'm going to put 630. Then where I have 1, I'm going to put what? 100.
110.
100. And others will remain the same. You go ahead and look for determinant of. I think you will do that. You do this. You use the same steps to get determinant of F, using the same way we did for determinant of F. Then if you need, and you realize that after doing that, your F, you get determinant of F divided by determinant of A, you will have the same value. You'll find that your F will be equal to what? What was our F? F should be equal to 70. If you get the determinant of F divided by determinant of A, your F should give you, or your F should be 70. Then for E, to get E, To get E, you will get determinant of capital E. Here you put capital E. You will need capital E, your matrix E. But where do you find E, colleagues? Which column? Where do you find it? It is the last column, eh? So we replace that last column. Where you have 1, we put
Yeah.
100. Then where we have 4, we put. So you just keep on replacing. Other things remain the same. This is 110. Once you have matrix E, look for the determinant of E. Then once you get the determinant of E, get that determinant of E divided by determinant of A to be at the end when you solve your E should give you what? Was it 10?
It's 10.
Your E should give you. If you solve, colleagues, your determinant of E will be equal to 20. If you solve, you solve in your free time. If you calculate, here your determinant of F will be equal to 140. So these steps, like the way we are getting this, it's about hiding, hiding, and you follow the concept that if I start with a positive, the next, when I'm handling this, I hide this, When I'm handling this, I hide this, So you follow the same steps and answer. Any question? Which method is easier? This one or the first one?
The first one.
Okay, but if they say you use, but also this one, once you understand it, is not hard. It is not hard. Just follow the same concept. See whether you can actually get determinant as 140 by using the same steps we followed here. Okay. Remember, as you get the first determinant, it depends on the first matrix you formed. Other things you're going to do will be rotating, will be changing the first matrix. So that's all, colleagues.